Alright, use Kirchhoff's law to find the current in the 12 ohm resistors in the circuit shown below. Now, if you have been struggling to understand Kirchhoff's law, this video is for you. Now you have the circuit shown here. In this circuit, you have a point. This point here is known as a junction. So we can first label this circuit. So if you label this circuit, you have this as A, B, C, D, E, and F. Now what you have here is you have 8 ohm resistor, you have 6 ohm resistor, you have 12 ohm, 4 ohms, and 28 volts and 10 volts. Now we have to find the current in the 12 ohm resistor. Now for you to get the current in the 12 ohm resistor, you have to think about, okay, I need to consider the Kirchhoff's first law, which is Kirchhoff's current law, which is sum of current entering into a junction, or this I1, must be equal to the sum of current leaving the junction. Leaving the junction, you have I2. Then I3 also leaves the junction. So you have I3 now. So from this now, from Kirchhoff's current law, you have sum of current entering equals to sum of current leaving the junction. Now entering the junction, I have I1 coming into the junction. Then I have I2 and I3 leaving the junction. I2 plus I3. Call this equation 1. Now once this is settled, we have completely used Kirchhoff's current law. So we need to go to the second law, which is Kirchhoff's voltage law. And in dealing with that, we have to consider this A, B, C, D back to A. This is a loop. So this is, you can call this loop 1, then you fix the direction of the current. Okay, that when the current is going in this direction on loop 1. Then again you consider A, D, E, F back to A as another loop. Take that as 2, let the current be going this way in 2. Now, in this now, if you look at the direction of the current enters into the resistors through this path. That path which the current enters through the resistor is called the positive terminal, and this is the negative terminal. Here you have positive coming in through this, negative going out. Here also coming in through this positive terminal, going out here you have negative. The longer part of the potential of the battery is a positive, and this part is a negative. Current is coming in through this part positive. Again, you have this part as negative, and here also you have the shorter part negative, and you have this part as positive. Once that is settled, you can now apply Kirchhoff's voltage law. But in dealing with that, positive sign shows a region of higher potential, negative sign shows a region of lower potential. So at this point, when you are from positive to negative in the direction of the current, if you move from the positive region of higher potential to the region of lower potential, we call that a potential drop, or what we call loss in potential. Drop or loss is denoted with negative sign. And when you move from the region of lower potential to the region of higher potential, we call that potential gain, and that gain is represented with positive sign. Alright, so for this now, we'll consider this first loop in the direction of the current. So we're going to consider loop 1, and that is A, B, C, D back to A. Now check the direction of the current. If you start from this part, you go from the region of lower potential to the region of higher potential. Then you have what we call potential gain. You write that as 28. Still moving in the direction of that current, you come to this part from the region of higher potential. You are coming to the region of lower potential. From higher to lower, you have potential loss, which is negative. But remember from Ohm's law, potential is product of current and resistor. So the current here will be multiplied by this resistor, and that will be minus 8 I1. Similarly again, in the direction of the current, you come back to this part from the region of higher potential to lower potential. That will give a potential drop, which is still in the direction of this current I2. So So you have minus 12 I2 all equals to what? 0 for the first loop. Then we'll do that for the second loop again. But we can still reduce this. Reduce this now, you have minus 8I1 minus 12 I2 equals to positive coming over to this part minus 28. Negative is common in all, multiplied through by negative 1. That will give you 8I1 plus 12I2 equals to 28. Call this equation 2. Now, similarly, I need to consider again loop 2. For loop 2 again, that is A, D, E, F, A. A, D, E, F, A in the direction of the current. If you move in the direction of the current, you go from a region of lower potential to a region of higher potential. From lower to higher is a potential gain. So that will give plus 12. And in the direction of the current there is I2. Then come back to this part again, you move from region of higher potential to lower potential. From higher to lower is potential drop, which means minus 6. The current in this direction is I3, 6I3. Then come to this part for the potential. You move from a region of higher potential to lower potential. Higher to lower means potential drop again, which is minus 10. Then for the last part, from a region of higher potential to a region of lower potential, you have 4, which should be negative 4. But the current in that direction is I3, which is I3, and that will be equal to 0. Now, something is common here, I3, I3. So we add I3 together. At this point, you have 12 I2 minus 6 minus this will be minus 10 I3 minus 10 equals to 0. So if you rearrange this, 12 I2 minus 10 I3 equals to, take this 10 to the other side, positive 10. Call this equation 3. Now equation 1 is available, 2 is available, 3 is available. I can either solve this simultaneously or solve this using the Cramer's rule. So let's go from simultaneous equation, which is the substitution method, from equation 1. We have it that I1 equals to I2 plus I3. That is our equation 1. Put equation 1 or substitute equation 1 into equation 2. And where's equation 2? 8I1 plus 12I2 equals to 28. Anywhere I see I1 here, I turn that to I2 plus I3. So write equation 2, 8I1 plus 12I2 equals to 28. Now that will be 8. I1 is I2 plus I3 from this part plus 12I2 equals to 28. Open the bracket here. 8 I2 plus 8 I3 plus 12 I2 to give 28. Now you have 8 I2, 12 I2. We can add this together. 8 plus 12 gives 20 I2 plus 8 I3 equals to 28. Call this equation 4. It is possible for us also to make I2 the subject of formula in equation 3, such that at the end of it, we will put whatever we have there into equation 4. So from equation 3, make I2 the subject, and that gives equation 3, 12 I2 minus 10 I3 equals to 10. That shows that I2 will be, you take this to the other side, 10 plus 10 I3, all will be divided by 12. Call this equation 12. So let's substitute 20, then I2, then plus 10I3 over 12 plus 8I3 to give 28. So we open this bracket, 20 times 10, that will give 200 plus 200I3. To save ourselves from the stress of using our LCM, just multiply 12 times 8. That will give plus 12 times 8 is 96. I3 equals to 12 again multiplied by 28, which will give you 336. We can connect the right terms now. 200 I3 plus 96 I3 equals to 336. Bring this here minus 200. So 200 I3 plus 96, that gives 296 I3 equals to 336 minus 200, 136. Therefore, we divide both sides by 296. I3 will be 136 over 296. 136 divided by 296 will give 0.459 approximately 5, and that is in ampere. Now that is talking about the current that flows through the 6 ohm resistor and the 4 ohm resistor, not the 12 ohm resistor. So I need to get the value of I2. So you can also put I3 equals to 0.4595 ampere into equation 5. Into 5, because 5 here is giving us the value for I2. So I2 will be 10 plus 10 in the bracket of I3 is 0.4595 over 12. So that will give I2 will be 10 plus 10 times 0.4595. That will give us 4.595 all over 12 plus 10. That gives 14.595 over 12. Divide this by 12. Divided by 12. That gives 1.21625. This will be approximated as 1.22 ampere. Therefore, the current in the 12 ohm resistor is 1.22 ampere. And that is also possible if you still want to get the current I1 now. So if you need I1, I1 will just be I2 plus I3. The value that you have here plus the value of I3, that will give you I1. So therefore I1 will be I2 is 1.2163 approximately plus I3 0.4595. So therefore I1 will be 1.2163 plus 0.4595, and that gives 1.6758, which you can approximate this as 1.6